This is our final video in our series of 4 on fertilizers. In this video, we will discuss the contact process. Now, just to give you a quick update, we are busy with producing 2 different compounds that is used in fertilizers, namely ammonium nitrate and ammonium sulfate. And we've done the Haber and the Oswald process, so the last one is the contact process that is used for the manufacturing of sulfuric acid. Okay, let's start. First step of the contact process is just sulfur and oxygen that you burn together to get SO2. This should be a very familiar equation that you did in grade 9. Then I take my sulfur dioxide and let that react with oxygen again to give me sulfur trioxide. Again, I am just going to go through the steps. These equations are not balanced yet. And then my next step, I take sulfur trioxide and let it react with a little bit of sulfuric acid to give me H2S2O7. Now, many of you may say, no, this is strange. I want to prepare H2SO4. How can I use H2SO4 to prepare H2SO4? I mean, then how was the first H2SO4 ever produced if you needed to prepare it? Well, to answer that question, the very first preparation of sulfuric acid was not done by the contact process. This was other ways. This is how we do it in industry. And in industry, strangely enough, they use a little bit of H2SO4 to produce H2SO4. Okay, so back to my third step. SO3 plus H2SO4 gives me H2S2O7. Now this looks like a very foreign compound, but actually, if you closely look at its different components, it's not so difficult to remember. I've got 2 hydrogens here. I've got the sulfur from my sulfuric acid as well as the sulfur from the SO3, which gives me 2 sulfurs here. And if you add up all the oxygens, there I have 3 oxygens and there I have 4 oxygens, and that gives me 7 together. So can you see it's actually just a combination of these 2 compounds? Nice. Okay. By the way, H2S2O7 is called oleum, as you see here. Okay, so now we've produced oleum. And if we take oleum and let it react with water, that will give us the sulfuric acid. So all in all, the contact process consists of 4 steps. Sulfur plus oxygen, sulfur oxide plus oxygen to give me sulfur trioxide. Sulfur trioxide plus sulfuric acid to give me oleum, and oleum plus water to give me sulfuric acid. So now let's go and balance these different equations. Maybe you remember from grade 9 that S plus O2 to give me SO2 is already balanced. So let's look at the next equation. I've got 1 sulfur on this side, 1 sulfur on that side, so sulfur is balanced. I've got 4 oxygens in total on this side, but only 3 on that side. So I'm going to need more oxygens. So I start by adding a 2 in front of the oxygens, which will give me a total of 6. Okay, but now my sulfurs are upset again. I have 2 sulfurs on this side, so it means I must have 2 sulfurs in front of this one. So now let's see if this new balancing number influences the oxygens. I have 4, 5, 6 oxygens on this side and 6 oxygens on that side. So my second equation is balanced. Now let's look at the third equation. If you remember correctly, a little bit earlier I showed you that if you just add all of these together, you will get that side. So everything should be balanced. 1, 2 sulfurs on this side, 2 sulfurs on that side. 3, 7 oxygens on this side, 7 oxygens as part of the product. Hydrogen, 2 hydrogens on this side, 2 hydrogens on that side. So this equation is completely balanced. Let's have a look at the last step. In the last step, let's check our hydrogens. 1, 2, 3, 4 hydrogens on this side, but only 2 hydrogens on that side. So that tells me that I need a 2 in front of this whole thing. 2 sulfurs over here. There's 2 in front means there's 2 sulfurs on this side. 7, 8 oxygens on that side, and 2 times 4 gives me 8 oxygens on this side. So these equations, although there's one more step than the Oswald process, I think the balancing of the contact process is much easier to remember. So for me personally, the most difficult process of the 4 to really remember and write down is actually the Oswald process. Okay, so let's quickly recap. This chapter is all about producing fertilizers. And the 2 fertilizers that we're going to look at is ammonium nitrate as well as ammonium sulfate. In order to make ammonium nitrate, I need ammonia as well as nitric acid. Ammonia I produce using the Haber process. Nitric acid I produce using the Oswald process. Our second fertilizer is ammonium sulfate. To produce ammonium sulfate, I need ammonia gas as well as sulfuric acid. In order to produce ammonia gas, I need the Haber process. In order to produce sulfuric acid, I need the contact process. Right now, I refer to the 4 processes. That was a little bit wrong. We actually did only 3 processes, Haber, Oswald, and contact. I think these 4 processes standing here, the Haber that's kind of overlapping, was that kind of threw me off. I think it is important for you to be able to write down a flow diagram like this one that I have here for each of the 2 fertilizers. Okay, let's quickly go through this one again. I have ammonium nitrate. In order to get that, I need ammonia and I need nitric acid. To get ammonia, I use the Haber process. But in the Haber process, I need nitrogen as well as hydrogen. Where do I get the nitrogen and the hydrogen from? I get it from Sussel, the hydrogen, and I get the nitrogen from the fractional distillation of air. Remember we did that in a previous video. Okay, in order to get nitric acid, I need the Oswald process, and you must be able to write down the balanced equations, all of them, for the Oswald process. The second fertilizer that I need to create is ammonium sulfate. So where do I get ammonium sulfate from? From ammonia as well as sulfuric acid. Ammonia I get from the Haber process, and sulfuric acid I get from the contact process. And you need to be able to write down all these balanced equations. And then in the Haber process, you must also know that nitrogen, where nitrogen and hydrogen comes from. If you are able to write down these 2 diagrams off by heart, this one creating ammonium nitrate and this one creating ammonium sulfate, then you are well on your way of understanding this chapter. It's also very useful to write down a flow diagram like this one. Often in the exams, you will see that they give you a part of this flow diagram and then ask you questions. They omit some of these labels, and you either have to fill them in or give the names of processes and so forth and so forth. Okay. Oh yes, I see in this process, by the way, that's one of the things I did not mention. In the contact process, if you take SO2 and you let it react with oxygen to give you SO3, your catalyst that you use is V2O5. So there's just some information there that I left out. And then in the Haber process as well, I left out also the catalyst for that one, which is iron or iron oxide. That is important information to take note of. So I do encourage you, maybe make a screenshot of this flow diagram. And if you are able to copy this one off by heart, then I think you would be quite well on your way of understanding fertilizers. This is your last question in the exam. These are easy marks. Go get them.